This is going to be a video going over Etm.1.lol diagrams. The reason that we use lol diagrams is to understand what's happening with the energy transfer given a particular problem. We have a couple different buckets or reservoirs that energy could go to or from. Kinetic energy. We use the K to represent kinetic energy. This is present when something's moving. So if I'm running on a track, I have kinetic energy. The next energy is gravitational potential energy. This occurs, or this is present, when something is at a higher position. So for instance, my pen right now has no gravitational potential energy if I consider the floor to be my base, but if I raise it up, now it has some gravitational potential energy. So there's two things to understand here. One, define a base. This is going to be the lowest point in a particular situation or problem. And then secondly, this gravitational potential energy is present if an object is raised up past the base. Okay, spring potential energy. If a spring is extended or compressed, if nothing is happening to the spring, if it's at its resting length, there's no spring potential. So this only happens when a spring is compressed or extended. Fourthly, thermal energy. This occurs when an object will heat up. So if I take my car out to California on a road trip, the car's tires will have a higher delta E thermal because I can feel them and I feel, oh, the wheels are hotter, so there must be some energy there. And this occurs when friction heats things up. You can feel this for yourself at home. If you take your hands and you rub them together, you're taking kinetic energy because your hands are moving and transferring it to thermal energy. The last thing I have put in a dash circle, which is work, which really isn't a type of energy, but we're going to talk about work and how it will change the energy within each bucket or reservoir. So if work is happening onto a particular thing or object, then the energy will change. For instance, if someone's on roller skates and they're totally still, their kinetic energy is 0. But if you come up behind them and you give them a big push, you're doing some work, you apply work, the energy changes. You increase the kinetic energy of this person on roller skates, and now they're going to move forward. Okay, so let's look at a lol diagram for this situation. You're on top of a cliff, you're holding a rock up, and you drop it. And you're curious about how fast the rock will be moving when it gets to the bottom. But before you do that, you want to draw the lol diagram for a couple different points. Let's say you drop it, you want to draw a lol diagram for that point. When the rock is here, you're curious about a lol diagram when it gets here. And lastly, right before it hits the ground, D. Okay, let's draw, we're going to draw 4 L's for A, B, C, and D. Let's do this in pink. Okay. So here is my first L, but before I do that, I'm going to define my system. That goes in the circle. Everything that I see needs to go in the system. I see a rock, I see a person, cliff, earth. Okay, then I'm going to draw a second L, and this will represent B. That's A, and then I have 2 more L's that I need to draw. C, and lastly, I'll squeeze this one in here, D. Alright. We could have different energies for each different point. K, U, G, oh, yikes, US, Delta E only goes in subsequent L's. It doesn't go in the first one because it's talking about a change in, and it's not defined at a particular initial condition. So here I go, delta UG, US, delta E, K, UG, US, delta E. Okay, now I'm ready to talk about what's happening to the energy at each point. Well, at A, you're dropping the rock from rest. Dropped from rest. So the rock is not moving initially at A, but it does have some UG. Oh wait, I have to define a base. Let's do that right now. I'm going to define the ground to be my base. Alright, so there's definitely some UG here. And I'm going to give it some blocks. It's arbitrary. I could have given this 6 blocks, 8 blocks, 4 blocks. I'm going to give it 5. Is there any spring? No, there's not. So that's my first L. Then I go to B. Well, I know that I have some UG because it's still up off of my base. I know this is present. But now at B, this is moving, isn't it? So I also have K. No spring. And let's say that there's no air resistance. So there's no friction, meaning there's not going to be any increase in temperature of the rock. So I have these 2 buckets now. Well, I'm going to give this, let's say, 4 for UG and 1 for K. Why did I do that? Well, if I started over here with 5 for UG and then the rock moved to a lower position, there must be less UG here in B. And some of that energy, the energy block, went to K. So overall, I still have 5 blocks. Over here, I still have 5 blocks. Things are balancing out, and that's what we want. Energy will move from one bucket to another, but the overall energy will stay the same. Okay, C, it's even lower, but I still have some UG. I still have some K. Let's say now there's 3 blocks, which means there's 2 for K. Overall, I still have, what, 5? No spring, no delta E. And then finally, well, it's reached its base. It's the moment before it hit the ground. It hasn't hit the ground yet, but it's pretty much at the base. So I'm going to say no UG. All of it goes to K. 1, 2, 3, 4. Still no spring. Still no air resistance. And I still have 5 blocks. That is the LOL diagram. In the next video, we're going to look at the expression that we'll come up with from this LOL diagram.